This is Junayd, and in my video I'll be talking about logic and Boolean algebra. So what is logic? Logic is essentially the science of correct reasoning. It is also known as to test the validity of an argument through reasoning. Let us take a real-life example. My friend here, Tony, is very hungry and is eating a lot of food. So from this we can say, if Tony is hungry, he eats food. If Tony is hungry is the condition, he eats food is the conclusion. A condition is an event or circumstance which must take place in order for something to be true. A conclusion is an event which takes place as a result of the condition being true. With logic, there are some things to keep in mind. These conditions and conclusions are theoretical, which means they are not necessarily realistic, just like the word problems in math class. For now, logic is used to see if conclusions and conditions make sense with each other. Cool? Cool. How did logic come about? Aristotle of Stagira was also known as the father of logic. He came up with something called a syllogism. A syllogism, a syllogism. A style of logical argument which had two conditions and a conclusion. It also came with some basic rules. Identity is what it is what it is, not contradiction. A cannot be and not be A at the same time. Either or, it can be either A or not A. And they were structured like this. Aristotle also came up with something called a valid argument. A valid argument, according to him, was a situation in which both the conditions and the conclusions are the same. In this case, these two lines are the conditions, and this is the conclusion. Let us take another real-life example. Some people are hungry people is one condition. All hungry people eat food is the other condition. So we can say, therefore some people eat food. These are the conditions, and this is the conclusion. It is safe to say that this is a valid argument because only some people are hungry people. Some people are hungry. Whoever is hungry or tend to eat food. Therefore, it would be safe to say and sensical to say that some people eat food. Some and all in this case are called quantifiers. And the conclusion is always denoted with a therefore to show that this is the final say in the matter. Syllogisms were very common back in Aristotle's time, but it had some drawbacks. There were not enough quantifiers to represent every situation. They only had all, no, and some. There were also very few correct inferences from all 126 possible combinations, only 11 of which were correct. A correct inference would be to say all poodles are dogs, all dogs are animals, therefore all poodles are animals. It would be incorrect to say all poodles are dogs, all animals are dogs, therefore some poodles are animals, because it does not make sense to say that all of the animals in the world are dogs, and it would not make sense to say some poodles are animals. George Boole was a very famous mathematician who came up with a way to approach logic in an algebraic manner. He called this Boolean algebra or propositional logic. What it is essentially true or false. These propositions are not necessarily realistic, but they still apply to logic. This man right here, for example, says that the sky is clear. He is true if he says if the sky actually is clear. If he is false, however, if he is referring to the same sky which is now cloudy and rainy. Several propositions can be combined to form several situations. With or, and not. In this case, let us say A is the sky is clear, B is the sun is bright. This situation can be stated as the sky is clear or the sun is bright, or A or B. This situation is true if the sky is clear or the sun is bright, or both. A truth table is a way of organizing all possible outcomes of the situation. In this case, the A or B is true if either A is true, B is true, or both. And in this case, we'll keep the same conditions as or, except in this case, they're both combined as A and B. In this case, A and B is true only if A is true and B is true. Or this situation is true only if both the sky is clear and the sun is bright, not either or. Not is an inverter, which means it changes true to false and vice versa. So if I say, for example, the sky is clear, the not changes it to the sky is not clear. So if it is true, it's false. If it's false, it's true. So then what's Boolean algebra? It is a branch of mathematics which deals with logic connectives and only has ones and zeros, where T is 1 or true is 1 and F is false or 0. Logic connectives are substituted by math operations this time. So AND would be multiplication, OR would be addition, and NOT would be a negative, also shown as an exclamation mark or a apostrophe. Logic gates are commonly used in computer science to analyze physical computer circuits. Gates is just another way of saying symbols. This logic gate shows the AND connective. So this says A times B. This is a NOT gate, which shows not A, and this is an OR gate, which shows A or B. These gates are usually combined to form more gates. So, for example, NAND is from NOT and AND. Logic circuits from gates. These logic circuits are made to represent the calculations as well as the structure of several computer circuits, such as the motherboard right here. These Boolean expressions can be derived from logic circuits and vice versa. You can get logic circuits from Boolean expressions. So let's take this logic circuit for example. Since the OR gate is also addition, it would be safe to say that it would be A or B, or you can also say A plus B. Since the AND gate is multiplication, you can say that it would be C times A plus B. So all in all, we can say from this circuit, this situation is represented by C times A or B, C and A or B. Just like common algebra, Boolean algebra also has properties. Some are very similar to common algebra, such as associative property. The answer will be the same no matter how they're grouped. The distributive property, the commutative property, where the answer is the same regardless of the order. Some are also very exclusive to Boolean algebra. Idempotence means it gives the same value. So if the terms are repeated, such as AA or A plus A, it will return the same value. Complements. Anything or its opposite is true or 1. Anything and its opposite would be false or 0. There's also a special property called the union and intersection, where anything and 1 would be A, anything and 0 would be 0. Anything plus 1 would be 1, anything plus 0 would be A. Logic is a science. It involves the consistent testing of an argument through reasoning in a certain context. It is ever growing and has several applications in the real world, such as computer science. Thank you very much for watching, and I hope you have learned something new today.